All right, guys, the last one I'm going to look at is this example C right here, where you've got these two things written in sigma notation, and they're very similar. They have one slight difference. The lowest term over here is going to be 0, while the lowest term over here is 1. Now, for both of these, we want to find their sum. That's what the sigma notation means. And for the sum, we need n. We need to know how many terms there are. We need to know the first term. And then we're going to do 1 minus rate to the nth power over 1 minus the rate. So we need to find 3 key numbers for both of these. We need to find the n, the r, and the first term. So for this first one, we're starting at 0 and we're going up to 10. If we're counting how many terms that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. Since we include 0 in there, it adds that extra term. So it brings our n up to 11. And then on this other one, we're going from 1 up to 10. And so when we count those, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. So that's one major difference between them, is that the one on the left is using one extra term. Next, we need to know the rate. Well, the rate is actually what's here in parentheses. So the rate is going to be 1/2, and the rate for this one is going to be 1/2. And then last piece we need for both of them is our first term. We need the first term for both of them. So to figure out the first term, you need to take this lower limit and plug it in to the equation. So for this first one, I'm going to be taking 6. Let me rewrite that. AF equals 6 times 1/2 to the power of 0. And for this other one, I'm going to be using 6 times 1/2 to the power of 1. So for both of these, you need to know your exponent rules. Any number to the power of 0 is 1. 6 times 1 is 6. For this one, any number to the power of 1 is itself. So 6 times 1/2 is 3. So I have my two first terms now. So I have all the numbers that I need. I need to plug them into this formula. All right. The sum of these 11 terms is going to be 6 times 1 minus 1/2 to the 11th power over 1 minus 1/2. Now, this can get a little confusing. You have to know your fractions, you have to know your exponent rules, and you have to keep all these numbers in the right spots. So, order of operations. Whenever you have a fraction raised to a power, both numbers in there are raised to that power. So I end up with 6 times 1 minus 1 to the 11th power is 1. 2 to the 11th power is 2,048. And 1 minus 1/2 is 1/2. So a lot of weird numbers in here. If you have your calculator, which you will, if you have your calculator, you can use it to figure out these tiny, tiny numbers. But 1 minus 1 over 2,048, I'm going to work it out right now. 1 divided by 2,048, and then 1 minus minus 1 divided by 2048. All this inside here works out to be 0.9995 and so on. So almost 1. So when I multiply that by 6, I get 5.997 over 1/2. Now, dividing by a fraction, you have to keep, change, flip. So I'm going to keep my numerator. I'm going to change my sign, and I'm going to flip my second fraction. So dividing by 1/2 is essentially the same thing as multiplying by 2. And so what that gives me is 11.994. That is the sum of these 11 terms. Now, I wrote really big, and I kind of got over in my space for the other problem. So I'm going to divide this up a little bit here. Just going to divide that off. And then I'm going to work my sum over on the right side, and I'll write a little smaller. So I'm looking for the sum of 10 things here, and it's going to be the first term, which is 3, times 1 minus the rate to the 10th power this time over 1 minus the rate, which is 1/2. So very, very similar setups here. But for this one, when I work inside my parentheses first, I'm going to do 1 divided by 2 to the 10th power. And then I'm going to do 1 minus that number. I'm just using my calculator off screen here. So I get 3 times 0.9990 over 1/2. Now, these numbers are really similar. They don't actually have a difference until their third digit right here. Very, very similar. Then I multiply that times 3, and I get 2.997 over 1/2. And remember, dividing by 1/2 is the same thing as saying times 2 when I keep, change, flip. Okay, I'm going to keep, change, flip. And so when I multiply that by 2, I get the sum of the 10 is 5.994. So very similar numbers here. Very similar numbers. The difference in them came down to that one extra term being there, because this 6, A0, ended up being the difference between them. This one included A0. This one did not. And so that whole term was missing. Hopefully that helps with the sigma notation.